Let's review Unit 1, Section 1-1, change in tandem. A function is a relation that maps a set of input values to a set of output values such that each input value is mapped exactly to one output. One input cannot have two different outputs. Other than that, it's not a function. Till we learn in a different way, we just keep in mind every x value will have only one and only one output. Let's say x is equal to 1. Then the output, which is the y, let's say is equal to 2. We cannot have, or if we say that, let's say x equal to 1, we cannot have y equal to 3 or 4, or because one input only produces one output. Not one input cannot produce two different outputs. If that happens, it's not a function. Let's note that earlier courses that you took, you might use the vertical line test to determine if a graph is a function or not. But later in this course, we will learn that this test does not always work. So the set of input value of a function is called the domain. And the domain represented by the independent variable. I'll write that IND, and the variable is x. It's independent variable or x. And the set of output value of a function is called the range, which is the dependent. Also is the y value. So knowing this, let's sketch this given function which has this closed interval. It goes x will be greater than or equal to -4 or less than or equal to 4. So we're using a closing interval which is -4 and 4, which means we cannot have beyond -4 or beyond 4. We cannot have -5, -6, or we cannot have 5, 6, 7 also. We're only stopping it from -4 to 4. So let's write this phrase given as a function. The function f will have each input value. What does it mean half? It will be 1/2. Each input value, then it will add by 2. Let me write the function given the expression. Given the phrase. So it has 1/2 of x, which is the x. We're halving x, then we will add by 1. So now let's sketch this graph. How do we sketch it? We will use the old way that we figure out when we took the algebra 1. We use the t-chart or t-table. So I will use, my interval is only between -4 and 4. So let me pick up all the even numbers, which is 4. No, let me start just the top, +4. Then it will be 2. Then we know 0 will produce, any 0 will be helpful. Then we have -2 and -4. So we're using a direct input. We're replacing it directly, all this value where we see the x. So it's 4. 1/2 times 4 is 2. 2 plus 1 is 3. Now x is 2. 1/2 times 2 is 1. 1 plus 1 is 2. Now x is 0. 1/2 times 0 is 0. Plus 1 is 1. -2. 1/2 times -2 is a -1. Plus 1 is a 0. -4. 1/2 times -4 is -2. Plus 1 is a -1. So we have the x and y coordinate. Then we just find the points from the coordinate plane. So now 0 goes to 1. Then we label that. Now 2 goes to 2. 4 goes to 3. -2 goes to 0. And -4 goes to -1. Then it says sketch the graph, so we just connect the dot. Even though my line is not straight, it's a straight line. And do not go beyond 4 and -4, because that's where the graph is stopped. If you are not given a conditional interval, then we can extend the line all the way to positive infinite and negative infinite. So now let's go some over concept review. I know we've seen it prior to this class, increasing and decreasing it. We will learn a 2 new concepts, which is concave up and concave down, which is called concavity. But before we know that, to read a graph, in order for me to know the increase and decrease in concave up and down, where do we move? We read the graph from left to right. Every graph we read from left to right, not right to left. We read from left to right. So if you can see this graph, it says as the input value increase. Which input value are we talking? The x value, this line, the horizontal line. You can see -3, -2, -1, 0. You can see the number increasing it. The more the number increase, you can see the graph is increasing it from left to right. That's all we're looking for. As the input value increase, the output value always increase. Which means if a value, which is the left, is less than the right value, which is the b, then f of a, which is the y value, is less than the f of b, which is the other y value. So now then, how do I know? By looking at it, you always trace from left to right and then see if you're climbing up. If you're climbing up, then the graph is increasing it from left to right. Now it's the decreasing. The only opposite is the input always increases, whether decrease or increase, but the output is the one that makes the difference. The increase, the output always increase, but the output of the decrease always decrease. Which means if a is less than b, even though a value is less than b, then the a value will be greater than by the f of b. So how do I know it? With tracing it, always you trace from left to right. You can see the graph, I'm climbing downward or decreasing it downward, which indicates from left to right, I'm decreasing. So now there is a new concept that we haven't encountered prior to this class or this course. How do we know what the concave up and concave down? For just to know it more concrete, when we take the AP Calculus or the calculus in college, we will know the actual definition of the concept of the concavity or concave up and down. Now let's know the concave up is when you are facing up or upward or a smiley face. When we're dealing with the concave down, it's a downward or a rainbow, or when we're looking downward, opposite of you. You upward, you downward, or upward, downward, or a smiley face, a frown, or rainbow. Any way that you can remember, just remember if your graph is moving it upward, looking upward, then it's a concave up. If the graph is looking downward, the top is the maximum. This is where we'll learn a different later on what maximum and minimum is, then just know it upward and downward. What else we need to know it? The rate of change. What is the rate of change? Rate of change, you might not know it, it's just similar to the slope. If you can find, or if you know how to find the slope, then you know the rate of change. So every time that you see rate of change, just think about it, we're looking for a slope. So knowing that, let's go some different examples to see if we can use those concepts. So now we are given a graph, and then we would ask different questions based on this graph. So you say the graph of h of x is shown above. Use the graph to find the open interval, where the h has the following behavior. The way it behaves is just like that. So we just know that. So what are we looking for? The increasing or decreasing it, concave up, or conditions that combine increase and concave down, and decreasing and concave down. That's how they combine. Before we even answer those questions, let's just label where the graph is increasing and decreasing with different color. So that way when we start it, we know right away what we're looking for. So now let me use for the decreasing it, different color, and the increasing different color. If you can see the graph is -4. If I start from the left, you can see that I'm climbing downward, meaning I'm decreasing it. Where else am I decreasing it? From this point, which is the 0, and then I'm decreasing it all the way to 4. Also know that to find the increase, decrease, concave up, and concave down, we only deal in the x value, not the y value. We're not interested in the y value. We're only interested where the x shows decrease, increase from what point to what point. So now let's label the increasing. We're increasing it from this point to that, and then we're also increasing it from 4 to the 7. So now we can answer easily every question that we have. We're dealing with the increase. Where are we increasing it? Let me write it down here. Here, let me use the same color. This section will be then decreasing. Let me write DEC. And then here will be DEC. Then this section will be increasing it, INC, and then INC. So that's how I know where I'm increasing it and decreasing it based on the label. So now I'm increasing it where? We're increasing it from -2 to a 0, because after 0, then we're decreasing it. So we're increasing it -2, 0. Then we're writing a union. If you're going to confuse a union, just think about it. We're using it 2 different intervals combined together. So this and or union, then the other location of the increase is 4 to 7. Also, because the graph is top is here, so I'm stopping here. If it was an arrow, then we can move all the way out. So now we're moving. Let me put a line here. Now we're dealing with a decreasing. Where are we decreasing it? From -4 to -2. -4 to -2. Then union. Then we're decreasing it from 0 to 4. Now we're dealing a concavity, concave up. Where's the concave up? If you can see that I'm concave down from -2 all the way to 2. Let me put a color so that what I'm stopping. So we're stopping it right there. We're starting from there and we're starting from here. Concave down. We're starting from -2 to 2. It's a concave down. But the concave up is starting from 2 all the way to 7. Because this point we will learn later on is called inflection point, where the graph is switching concave down and concave up. But this does not have a concavity because this is a straight line. Then where is the concave up? The concave up is at 2 to 7. So now we're finding it both must be increasing it and concave down. Increasing it and concave down. Where is it? I know from here I'm increasing it and concave down up to a 0. But from 0, even though it's a concave down, but it's a decreasing it. So increasing it and concave down is, let me put it just line, the white line. Increasing it and concave down is just from -2 and 0. -2, 0. So now we have to look at both. It must be decreasing it and concave up. Decreasing it and concave up. I know from 4 is concave up, but it's increasing it. You can see that from 4 all the way to 7, even though it's a concave up, from 2 all the way to 7 is a concave up. But from 4 on to 7 is increasing it. We're looking for decreasing it. What are we decreasing it? Just from 2 to 4. That's all we're decreasing it, and concave up. We're looking for one section of the graph that combine decrease and concave up. So that it will be then 2, 4. Always you read the graph from left to right. So now we have different graph that we have to find the same way, concave up and concave down. The same way that we did earlier, before we find increasing, decrease, concave up and down, let's just color the label. Let's label. If you can see here, we have 1, 2, 3, which is -3. And then we have 1, 2, 3. From -3 to 3 is increasing. And then we're decreasing it. We have 1, 2, 3, 4, 5, 6. Let me label it as a 6. This point is 6. 1, 2, 3, 4, 5, 6. This is 7. So now we're decreasing it from where? We're decreasing it from 6 all the way to -3, and we're decreasing it from 3 to 7. Now let me write it down, by increasing and decreasing it, then we will come back from cavity. So now where am I increasing it? I'm increasing it from -3 to 3. Where am I decreasing it? I'm decreasing it this graph, but the question did not ask a decreasing it. It just asked increasing it. If the decreasing asked, we could use that. Now we're dealing with concave up. We're dealing with a concave up. Where is a concave up? Concave up where? I mean, not concave up, concave down. Concave down is just from 0 to 7. If you can see that this is downward, or frown, or rainbow. From 0 all the way to 7 is a concave down. So the concave down is from 0 to 7. Why am I using it open interval, not close interval? We don't know if the graph is continuation from here, because this point belongs to concave up and concave down. That's where the graph is switching it. So that's why we cannot use that value as a close interval. It doesn't belong to the concavity of up and down, or decrease or increase. We always use open interval. So now we have a different graph with different shape. So now we will label the same way that we did. Increasing it, we use the green color. We're increasing it 1, 2, 3, 1, 2. We're increasing it from -3 to 0 and 2 to positive infinite, because the arrow shows that. If we need it, we don't need it increasing it, we're dealing with decreasing it. Let me label it the decreasing. We're decreasing it from negative infinite all the way to -3, and then from 0 to 2. That's all we needed. You remember I labeled the green color from -3 to 0, then 2 to 7. If the question asks increasing, we could write the same way. Now we're using it combined answer. So we are decreasing it from negative infinite all the way to -3. Then union, then we're moving it from 0 to 2. Now we're looking concave up. Where is the concave up? As you can see that, let me use, this is a concave up. All the way here from the -1 is a concave up. And then where else are we concave up? From 1 all the way there. So this is a point of inflection where the graph changing it concave up, concave down, or concave down, concave up. So this one is where the graph is changing it, and -1. So I'm writing it concave up is -infinite all the way to -1. Then union, then we're starting it from 1 to positive infinite. That's all you needed to do. If you have a graph, you can read from the graph all your information, and it will be easy to find it. We should always know that we're using open interval, not closed interval. But when you take a calculus, you will learn the easy way to find whether you have a graph or expression or equation or a function. Whatever you have, it'll be easy way to find it. So now we have a question that has a multiple choice. We are given a graph. Which of the following are described best to describe the graph of this? We have A, B, C, and D. So now let's label the graph and see how the graph is behaving. I'm starting from the left. If you can see that, I'm climbing up, which means I'm increasing it. If I'm increasing it, I'm sharp turning it downwards, meaning I'm increasing it and concave down. This graph is increasing it and concave down. Even if I don't read the question, then I look for where they're increasing and decreasing. First on A says increasing it, which is correct, but it's concave up. It's not U-shaped. The graph is not U-shaped, so there's wrong answer. It's decreasing. The graph is not decreasing it, so this is not right option. Also, the D says decreasing. It's not the right option. But on B, it says increasing it and concave down. So the right answer will be a B, because we'll always trace the graph from left to right and then see if you increasing, decreasing it, then you can find whether the graph is downward shape or upward shape. So now we have points that were given for the increase and decrease, and we have to sketch the graph based on the information given. So now what information was I given? I was given the increase. I was given the decrease. Whether the graph is increasing it, interval, or decreasing it. I was also given concave up, and I was given concave down. Then I need to sketch this graph based on this information given. So let me write my label, my points here, so that way while I'm tracing it, I know what I'm tracing it from the graph. So we're increasing it. Where are we increasing it? -4 to 1 on 5 and 7. We are decreasing it. I'll be using the same color, so that way I know what I'm graphing it. We're decreasing it 1 to 5. So if you can see 1 to 5 will fall between these two intervals. You see that? This one will stop at 1, and then this one will start at 5, after 5. So this interval will fall between this increase. So now then I know where am I starting the increase, decrease. Increasing it will start at -4. I just put a 1 dot there. So just that I know it, let me use the same color so I can trace it later on. So now the -4, then I have 1 dot here. Then where else do I have 5 and 7? Is somewhere here. Now we have a decreasing it from 1 to 5. 1. and 5, somewhere 5 here. So now it's a concave up. Concave up takes place between the interval 3 and 6. You can see that this concave up takes from here, this way, that way. And then -4 and -3 and 6 and 7 is concave down. So now we're moving from negative, while we're keeping in mind -4 and -3 concave down, on increasing it, we increase that way. Let me put my label there. So now we did that, and then we did at the same time this. So now where are we moving it? From 1 to 5 is decreasing it. And at the same time is concave up, 3 to 6, decreasing it, and the concave up. Then 3 to 6. Then 6 to 7 is a little bit decreasing. So that would be the rough sketch. It might not be the exact graph, but I'm moving it, increasing it and concave down up to that point, and then I'm decreasing it concave up from this point to that point, then I'm decreasing it and concave down. That would be a rough sketch.